Good morning, mathematicians. Guess what? It turns out I'm not as silly as of a goose as I thought, and that thing I was stuck on yesterday, it's actually a typo in the book. I found a Stack Exchange post about it. So, that's good news for me. And it's good news for you, in case you were also confused about it. Wait, why did I... oh wait, this is me now.
Not as silly as
so
goose as I
confused.
thought, and that
Hello,
thing I was stuck on
ownage
yesterday.
effects.
It's actually a typo in the book. I found it.
Okay, just got to get myself sorted out here. I was thinking about making another Vixra review, but actually it's a lot of work because some of those papers, their errors are buried deep. But maybe I should still try. Okay, where are we here? Spectral User's Guide. Ouch, she didn't realize McCleary had any typos. Now you wonder about the few times you got stuck in it. Yeah, could be. I mean, every book has typos, right? It was very funny. So I was watching that that Kevin Buzzard talk about kinds of equality, and of course it is basically just well, let's maybe not say isomorphic, but let's say homomorphic with small kernel and co-kernel to his archive paper, which I've not only read but suggested to quite a few other people to read. But there was some he was saying something about there's some book or paper on something about Brian Conrad, who he was saying is known to be a very famous mathematician, but known to be, I mean, yes, famous, but careful mathematician. And then, at the start of this book, he says something. He's like, what did he say? I believe he said some sort of like, oh, I believe, or I think that there may not be any errors in this paper. And then there's like, a whole bunch, but they're all typos and sign errors apparently. So nice. Yeah, we love to hear about basic Banach space theory and LP norms. So glad you're enjoying. Okay, so anyways, with that typo resolved, I mean, if you Google example 1A McCleary Stack Exchange, you'll find the resolution. So let us move on to Lacunary phenomena. But only after we pour ourselves some coffee.
This is my favorite part of the morning. In fact, this is my favorite part of any day. Legal drug addiction.
Okay. Suppose that our generic theorem 1 holds. Wait, what was that? Those are... what? Okay. Suppose that our E2 page is isomorphic to something computable and converges. Speaking of functional analysis, some days ago you mentioned some class of C-star algebras that should be analogous to CSAs, right? If you actually care, there's a book about Morita equivalents and Brouwer groups of those. Interesting. What's the book? But even the book does not explicitly mention the analogy. How much coffee do I drink a day? The vast majority of days, exactly one of these. Exactly one of those. Yeah. I'm what you could call a functioning caffeine addict. So the spectral sequence is said to collapse at the nth term if all of our higher differentials are 0. Of course, the immediate consequence of collapse of that term means, and we've recovered the graded vector space. Okay, we've got ourselves a big old example here. Suppose this thing on the E2 page is 0 above N1 or N2. Then the spectral sequence collapses above there. Yeah, believable. Because, you just plug it into the formula. Yeah, that should be fine. And these are two extreme cases. I see. You don't know how my heart is keeping... This isn't that much. A single French press? This is not that much, is it? I mean, it depends on coffee strength, but how much caffeine in a French press? Uh, 80 to 107 milligrams. RDI caffeine. Yeah, see? The RDI is up to 400 milligrams. So, my heart is keeping up with it just fine. Looks like a lot, but on some days... Also, I drink dark roast because I want to not overdo the caffeine while being able to drink as much coffee as I would like, and because I prefer the bold flavor. It looks like a lot, but on some days you probably drink the same, just in individual cups. Yeah. I mean, it's only, like, if you think of these mugs, it's like maybe 2 of these mugs full. Yeah. I would consider myself fairly conscious about my heart health. So, yeah. Okay. In case 1, these are just whatever. It's just formal computation. So, suppose this is 0 whenever P is even or Q is odd. Then the spectral sequence collapses at E2. Huh. We're not going to do the proof of this? Oh, we are going to do the proof of this. May seem artificial, but can occur when the E2 term page is given by a tensor product. Very interesting. Are graded vector spaces over K, where V is concentrated in odd dimensions and W is concentrated in even dimensions. Okay, let's bust out the writing tool for this one. I do want to... Ooh, get out of here. Get out of here. Okay. So we're going to look at R greater than or equal to 2. Right. So if this is non-zero, p plus 1, p plus q is congruent to 1 mod 2. Hey, we're doing number theory. Am I a genius? God, no. Am I good at? I don't know. Am I even good at math? Sometimes I don't know. I mean, it seems crazy, right? I've got preprints on the archive. I must be decent enough, but I feel like in the grand scheme of things, I'm like, oh, there's people with way crazier papers out there. So I don't feel like I'm that good at math. But yeah, compared to like the vast majority of people on the planet, I guess I'm like untouchable. But then, if you compare me to like typical working mathematician, I don't know, I'm probably average, maybe. Fun fact, I actually failed math in high school, but that's not because I wasn't. That's not because I was trying and having difficulty. That's partly because I was skipping class to partake in the green leaf, and I was teaching myself calculus, while failing. You've been following me for a while, but checked out my CV. Is it stacked? Yeah. Average among geniuses, still fluffing smart. Oh, okay. Well, I'll take the compliment. Computing the Serre spectral sequence of a complex projective space is a great instructive example. It's polynomial algebra in even degrees. We may come across it. I know I've peeked ahead a bit. I spoiled it for myself a little, and I do know that there's some polynomial algebra examples coming up. Okay. But this changes total degree by 1. Oh, so this would have to be 0. Right. So then the target would have to be 0, and so the map would have to be 0. Nah, I didn't even need to bring up the writing for this. Slacker stoner mathematician archetype strikes again. Yeah. Not supposed to be disrespectful question, but did it take you a year or two extra to get your bachelor's? It took me a lot of years extra, actually, because so after that, I started my bachelor's degree. And, I mean, well, it depends on how long you're counting. I started my bachelor's degree, and I only did about 1 semester, and then I dropped out, and then I just, partied for several years. Occasionally taking classes, because I was still interested in math, so I would occasionally go and take the odd graph theory course, or I took a course in set theory. But then I wouldn't say I seriously returned to school until 2015, and then at that point, and then I graduated with my bachelor's in 2019. So if you count from when I started taking it seriously, it was only 4 years. But technically, I had some courses under my belt since before that, so I guess it would have. I don't know. I don't know. I guess maybe you could count it as 5. But the actual time period from the very first time I went to university to degree in hand was much longer than that. It was 8 years or 8 years. Yeah, I guess 8 years. In the previous placements of holes, trivial vector spaces, in the spectral sequence force it to collapse. In the next example, the holes do not defeat the differentials, but restrict their possible action. Interesting. Suppose this is 0, unless Q is 0 or Q is N. Interesting. For some, it doesn't even say for all. It just says, right. So fix some N a priori, and then all of them will have this thing. Okay. Very interesting. Okay, so we have HP plus N. Okay. You did not care about class in your first year and got cooked. Yeah, same here, Brenner. Yeah, I even longer than that. I spent a lot of time, even though I was interested in math. I was reading like more advanced math, like in my free time for fun. I just hated doing homework, and so I did and so my undergrad transcript is bad. Maybe that'll be my 10,000 sub reveal, undergrad transcript reveal. And there's a long exact sequence. So why is HP plus N here? Why is that the kernel? Why is that the kernel? Or not the kernel, but why is it there in the sequence? I get why dn plus 1 is there. But why is HP plus N here? Because, like, yeah, this is very confusing. I mean, that should be an E2. Oh, I see. That should be, I guess, an E2, an E2P minus N Q Q. What's my brain power? Plus N minus 1. And so I guess this is, or, oh, sorry, N. Sorry, that's N there. So this would be N. This would be 2N minus 1. So I guess that would be 0. I guess that would be 0. No, I'm confused. Make more sense looking at the diagram. Okay, let's see. Well, he says to concoct instances of this. Ooh, this will be relevant for Leray-Serre. Pictorially are conditions obtain 2 stripes in which non-trivial data lie, as in the following diagram. 2 strips, probably. The only possible non-zero differential is this one. Okay. I still don't. Oh. Well, we're arguing. Hang on. By the placement of the trivial vector spaces in this term, the only possible non-zero differential is that. Therefore, we have collapsing and H. What is this notation? En plus 2 is what, the homology? Is that supposed to mean the homology at En plus 1? By placement of trivial vector spaces in this E2 term, the only possible non-zero differential is that. So this means we have collapsing? No, not quite. It just says all of these guys are isomorphic. And then En plus 2 is this. Every page is the cohomology of the previous page with respect to the page's differentials. Okay, but why? Why is that true? Because the differentials are 0. Right. Right. Every page is the cohomology of the previous page, right? But I'm still trying to figure out this term. Yeah. But where does this term come in then? Where does this term? I guess. Well, okay. Hang on. Well, this should be right. Well, we found out that term was 0. Oh, E2PN. E2PN, right, is the kernel of E2PN to E2, E1? Gosh. My memory is so terrible. Yeah, E1. So this is E1 PN P1 N over the image of E1 P minus 1 N E1 PN. I don't see how this helps me though. Okay, I believe this now anyways. I believe this much. And yeah, I still don't understand this notation. Why is this the E infinity? I guess all higher terms go away or something? Like, why is that? Why does it collapse there? Unclear. Now dn plus 1 is the 0 homomorphism on the bottom row. So, I guess he's trying to explain the proof. Okay. But I'm still stuck at this step. Is he just reminding us the definition? Why does it stabilize after n plus 1? The only non-zero differential is d. Dn plus 1 down below here. I see. So the higher ones have to die. Okay. The differential in later pages will be 0. Right. Okay. Yeah. Okay. Gotcha. Okay. So now dn0, dn plus 1 is the 0 homomorphism on the bottom row. Yeah, maybe I should write down So d n plus 1 from e to pn. Well, I guess I want, wait, dn plus 1 on the, I guess we can consider it on 0, right? Because we're saying we're basically saying it collapses at the, no, but we're only saying that E2 up to En plus 1 are isomorphic. And then En plus 2 is the cohomology of E2. In a sense, what's the cohomology of En plus 1? But, ooh. Man, I really got to figure out a way to stop my computer from doing that. I hate it. Okay. So on the bottom row, and so E infinity star 0. The 0 homomorphism is on the bottom row. Is 0 on the bottom row. Why? D. Hello, Pajama Man. D n plus 1. I mean, wait, I'm so confused by all of this. Shouldn't the sub of the differential match the sub of the sequence? Oh. Effectively, you have a bunch of chain complexes with two non-trivial objects and a map between them. Okay. But yeah, dr is, the subscript r is supposed to match the subscripts here. This looks kind of familiar. Should it? I don't know. Have you taken a course in spectral sequences before? Then it should. Also, I've been doing the same thing for 2 days, so. Right. Okay. Right. So. But I feel like this doesn't get any better if I call this n plus 1. I mean, setting... Are these exact sequences, or are you just seeing what you've been seeing for the past 3 days? Both. Both. I mean, to say that the bottom row is 0, I mean, if we set this, we take set n equal to 0. We get this. We set n equal to 0. Okay. Oh, I guess we wanted to set n equal to 1. Okay, E2 star 0. The sequence in this example starts from the E2 page. It does? Huh? Nothing about that was clear to me. The sequence, you can treat it like E1 was already computed for you. Okay. But E star, or E... Okay. EPQ infinity. Let's remind ourselves of this. EPQ should be FPH P plus Q, FP plus 1, HP plus Q. You mean you could imagine there was E0 and E1 before it, but they already told you the E2 page, so you start from there. Okay. Sure. But now, okay. So what does that mean? So that means that E star 0 E star 0 we know is well, let's go EP0 is FP HP FP plus 1 FP plus 1 HP. And I think we have the convention where so this should be 0. And so this is FP H intersect HP, right? Yeah, I don't know. I don't get it. I mean, E2, let's see, we have E2 P0 sits in a sequence of E2 P plus 2 minus 1 and E2 P minus 2 1. Yeah. I don't know. Slow morning. I'm just gonna have to call it soon, I think. I don't get what's going on here. Maybe this is one I'll have to work through myself later. The end result should be something like the inclusion of the kernel into E2 into the co-kernel. And then those are stitched together to give a long exact sequence in the statement. Well, okay. I'm just trying to understand this right here. Somehow E star 0 should be the co-kernel of this map. And that just doesn't make any sense to me at all. So I'll have to go and think about it. Long exact sequence in example 1C is the Gysin, however you say it. See exercises at the end of this chapter. Okay, well, maybe tomorrow we'll just move on to exploiting further structure. Looks like there's more comprehensible things here. Probably not. I'll probably get stuck on something silly again. Okay. Maybe I'll figure this out before tomorrow. But either way, that's going to do it for today. So